Cool. So point of today is let's do some cool TypeScript stuff. I have this very generic React application that got created using Vite, and I took everything out of it. This is our sandbox that I come back to every once in a while just to show off a little concept. So I'm in my sandbox right now. And before I really talk to you about what TypeScript is, I'm going to point everyone in the direction of a resource on the agenda today. I'm going to open up this GitHub discussion, which describes how you can install TypeScript onto a React project that was already created without it. If you are creating a new project that you want to do with TypeScript, it's very easy. You can just create v.latest, and then when it gives you the option, maybe not. What the hell is going on here? Okay. Uh, Very curious. Might do a quick reinstallation of code here to try and clear this out and restart it. Oh, come on. I don't want to reinstall everything. It'll take forever. This was unplanned. I apologize. But I guess we're going to update 90 homebrew packages just for fun. Jeez. I've seen my SQL like 7 times already. I don't even know what's going on anymore. Oh, right as I am ready to give up. That's when it finishes. Okay, reinstall, fix my note. Curious. All right, well, in that case, what I'm gonna do is I'm gonna go into that sandbox again. And we're going to just do what this Stack Overflow post says. If you want to create a new project with TypeScript, you can npx create Vite at latest, which hopefully this time will do something. Are you kidding me? Not npx. It's not npx. So stupid. All right, that whole thing was for naught. All right, so npm create Vite at latest, and you create your some projects. And you can say that I want a React project, and then here's where you would pick TypeScript at the top rather than just JavaScript, and it'll set all of this stuff up for you. But given that we have not done that, we're gonna have to do that ourselves manually. So I'm gonna do what it tells me. We have a couple of packages that we need to install. We need to install TypeScript itself, and then we need to install this @types/react and @types/react DOM. What's going on here is React and React DOM by themselves are packages that do not conform to TypeScript. They're just JavaScript packages. You can import them from other pure JavaScript programs. But if we want to be able to utilize a typing system on these packages have to declare their own object types. So everything you import, all the variables you use, all the functions you call, they are in TypeScript like strictly defined types, which is not a thing in JavaScript. We'll talk in a second why that's cool. But when you put @types in front of something, what we're actually doing is we're trying to install a different package that adds types to an existing JavaScript package. So this @types usually corresponds to a definitely typed version of the package. If we go in here, which is also in your links, this is a repository that is specifically for type declarations of existing packages. So if I go into the types here, these are all node packages. There are so many, and they've all been published as just JavaScript. And these packages declare these really disgusting types for the functions that are exported, for variables that are exported. Everything that you can use from the library is given an explicit type in these type definitions, which you see with .d.ts. If you're creating your own package, some people will like specifically create their own type definitions, which is great. Some packages are old and they don't do that. And so the community has gotten together and created these. So what we're doing here is we're not installing React DOM and React DOM again. Oop, you don't need to see my FaceTime. We're just installing a package that contains the types that belong to the React and React DOM package. And that way we can actually use these packages in our React project and get all the benefits of having a good, strong type system. Did that make sense at all? I get like a yes or a thumbs up from someone. It doesn't have to make perfect sense either, because we'll jump into it some. All right, I got a thumbs up. I had to open the participants tab. Cool. All right. Well, we're going to do that. We're going to npm install those three things. It should be very quick. Cool. And what else does it need us to do? In our sandbox, I close down this other tab that we're not using. Close this definitely typed page. And now we have to add some configuration so that our TypeScript compiler knows what it's supposed to do. So the TypeScript compiler is going to look through your whole project and try and find violations where you're not mixing your types properly, or you're not giving a type to something that's expecting a type. And so we have to just set up some configurations of very general boilerplate. The one thing that is important is we have to take all of our TypeScript React component files and compile those into vanilla React components. So if I create a component with regular React, I would name it app.jsx. But if I were doing this with TypeScript, I would name it app.tsx instead. And this lets the compiler know that it needs to check through this file. And this .jsx file, it's not going to check through it. So we need to use tsc, which is a command that you can use once you've installed the TypeScript package. And we are going to turn all those .tsx files into .jsx files. Again, what that's actually doing, we'll talk about it in a second. We're just going to blindly copy it for now. So we're going to go in here to our build, and instead of doing v build, we're going to do tsc ampersand ampersand. And when I'm executing a Linux or a Mac command, this ampersand means do the first thing, and if it's successful, do the next thing. And you could chain a bunch of these in a row. You could also do or, which will be a different thing, but double ampersand is pretty common. I can't use JSX files with TypeScript. You are allowed to still have JSX files, but you're not going to get any of the benefits of using a project with TypeScript. It defeats the purpose. And so if we're going to use TypeScript instead, we want to make sure that we're declaring all of our files as .tsx. .jsx is totally fine. It'll still work, but you won't get any help. It'll just be right like you didn't even have TypeScript. Okay. And then these configuration files, I'm just going to blindly copy in again. We're going to do tsconfig. We're going to create tsconfig.json. And then I'm going to take this whole file and just copy it in. This is declaring a bunch of options for how the TypeScript compiler is going to check through your work and the rules it's going to follow. There's a lot of rules. This is a very small number in comparison to what's actually allowed. I highly encourage when you're starting out to just like Google React TypeScript config file and just copy something from online. It'll have a lot of rules in it. Many of them you won't really care about. If you come across something that you don't like, then you can change it. But in general, we want to get like one TypeScript configuration file that has all the rules that I like as a developer and that my team has agreed upon. And then maybe we change like one or two things depending on the project structure. And you can literally just copy your config from an old project to a new project. But we don't have that yet, so we're just going to copy from the internet. And then similarly, we're going to do that for tsconfig.node.js. And again, what exactly these do, not super important. They're just going to declare a bunch of rules for us and let us use TypeScript. Cool. So with that in mind, we now have TypeScript on our React project, which is awesome. And what's the point? What are we actually doing here? Well, let's create a little sample here. We'll make this just a vanilla JavaScript file or TypeScript file. So instead of making it JSX, which implies that there is a React component in there, we're just going to make it .ts, which is the same thing as .js, except we're telling the TypeScript compiler that you should check through this and make sure everything's okay. So with that, let's see what we can actually do here. So, oops. If I were to write a JavaScript function called add numbers, and I take one number X and I take one number Y, Let's actually do this in a vanilla JavaScript file first, just so that see how this works in regular JavaScript. Okay, I have my JavaScript file. I have two numbers, x and y. I'm going to return x plus y. Very simple. We know how this works. No questions here. I would expect that the user is going to call add numbers and maybe give me like 1 and 9. Or add numbers and give me 27 and 3. And I can console.log to verify that these are the correct result based on what I'm expecting. And we can open up a terminal. And let's go into our source and we will run sample.js with node, and it will print out the two numbers that we added together. Super easy, no big whoop. You might not even be like expecting users to be writing code or other teammates of yours. It literally might just be you. You're working on this crazy big project, and eventually you accidentally make a little typo. And the third time we call this, maybe we have some variables. So I have my variable x, my variable y, and this is equal to 0 and 1, which we can't actually do for some reason. And then I have a bunch of code here, and I accidentally at some point write a bug where I assign y to be a new value. Maybe I accidentally make it a string, like maybe I'm doing 1 plus 2. Actually, this might actually work. Let's say we accidentally make this a string 1, or we accidentally convert the value of y into a string, whatever it is. So now if I console.log my value of y, and then I try to add those numbers together again, x and y, and I log that out, we're gonna see some weird stuff in here. Oh, that's not the weird thing that I was expecting. Huh, this is a little weird. If I log this out, it does tell me it's 1, but you'll notice this is a different color, so it's a string. And then when I try and add these numbers together, 0 plus 1, I actually get the string 0, 1, rather than the number 1. I could check the type on this, and this would be a string. Same here. So this is kind of a problem. Like I would, this function is explicitly declared because I want to add numbers. That's it. That's all I want to do. I just want to add numbers together. And I don't want to try and deal with the repercussions of, well, what if I accidentally pass in something that's not a number? I could like do a bunch of really complicated stuff in this function. Like I could say if x is equal to not a number, then we return 0 or -1. And then I could do the same thing here. I could return -1. And this helps if the thing that I actually pass in is the type, not a number. Like if I take a string and convert it into a number, this is gonna give me not a number. But this doesn't help if x and y are actually strings, or if I accidentally pass in null or undefined. Maybe I don't pass in the x accidentally. Or I don't pass in the y, maybe I just add 3 and then I don't give y a value. Then we're still gonna have some problems. Now it's not a number because it's trying to add 3 plus undefined, and we're just running some crazy stuff. This should not be possible. In any other programming language that is sane and has what's called static types, where every variable has to be a specific type, and if you try to use it as a different type, it's going to give you a red squiggle. JavaScript doesn't do that. JavaScript lets you be really loosey-goosey, which sometimes is cool. You can take advantage of that, but a lot of times Like, you're just causing headaches for yourself. Why is this value that I accidentally, that I got back from some function not what I'm expecting? Well, because you accidentally passed undefined instead of a string from a variable that hadn't been initialized yet or something like that. Just a lot of like really gross stuff. It would be really great if I didn't have to do any of this. I could literally just say, add my two numbers together. And my compiler, as I'm writing the code, would flag these and say, these aren't numbers. What are you doing, you dummy? And that's exactly what TypeScript is for. TypeScript is technically a superset of JavaScript, which means any valid JavaScript is valid TypeScript. All TypeScript does is it makes sure that when you assign data to a variable, or when you create a function, or you create a class, the value you're passing in place of that variable has to be what you're expecting. If I expect two numbers here and I pass in a string, it's going to highlight it immediately and say, that's a bug in your code, you should fix it. We find that bug as soon as we write the code, rather than we write some code, JavaScript tells us everything is fine, there's no red squiggles. We, write some tests for our code. There's a really complicated bug that's discovered in production, and we're spending hours and hours trying to debug, like, where did this come from? Why is the data not what we expect? And it's because you accidentally passed a number instead of a string, or a type was accidentally converted into a different type, and that was problematic. And so literally all we have to do here is just rename this to be .ts on the end, which sticks the TypeScript compiler on this file, and it immediately tells us we're doing stuff wrong. Like, that's all it took. We just changed the file name, and now it's pointing out all of the errors with this bad code. If we look up here, we see that it tells us this parameter has an any type. Any meaning I did not give it a type, and so I am allowed to pass any value in here, which is bad. We don't want that. In this case, it should specifically be a number. You'll notice that this says implicitly. Implicit means I didn't explicitly write a type for this variable. I could say X has to be a number and Y has to be a number. If I did actually want to let someone pass in any type, which has some use cases, you'll definitely do this every once in a while, but it's, the whole thing that you're trying to avoid, then I could explicitly say this can be any value. It doesn't have to be a number. But in this case, we want them both to be numbers, and so we can add these numbers together, and that's totally fine. This was a string, and this was a string. We can add those together because concatenating strings is fine. If this is like an object type, or maybe like an integer array, trying to remember what the syntax is for this off the top of my head. This is an object. It's still going to let us do this because in JavaScript you can add anything together. So that doesn't really help us. But what it does help with is down below, it shows us that these things that we're expecting to be numbers, well, here we were expecting two arguments, but we only gave it one. We're saying X has to be a number, Y has to be a number. Here, X is 3, but Y is undefined, and that's not valid. I have to give it two numbers to add together. So I could do that, and that'll go away. We got another error over here. String is not assignable to type number. When I declare this variable, it's going to automatically assign it a type based on the data that I'm giving it. And that's the type of this variable for its life. Until that variable goes away and is no longer in use, it's going to be a number. And that's good. We want it to be a number. If I accidentally put a string in there, that should not be intentional. And here, we're exactly right. We converted it to a string, but then we're trying to add it like it's a number, which is not valid. And so we can't do that. We can take that out because it's probably a bug we wrote somewhere in our code. And now if we run all of this again, we're going to be just fine. We can't do that. I think if we do this, trying to remember how to run this. I think we can do sample.ts. So TSC is the compiler. Which I would have expected to only compile this sample.ts, but that does not seem to be the case. TS. I think this is the other one that gets used pretty frequently. This is a package that lets you run using Node, a TypeScript file, whereas previously I can only tell Node to run a JavaScript file. Oh, that doesn't work either. Okay. I'm gonna do one more thing here. I'm gonna install something called Nodemon. And along with that TS node, now we're going to run sample.ts. What am I missing here? I think because I'm doing this in a React project, that's why it's not liking it. I think we could just do TS node here. So when I do -G, this is installing it globally, so it's not specific to this project. And then I can call it like a command here. TS node sample.ts. Okay, I think the TSC actually worked. Yeah. Okay, so TSC takes our TypeScript and converts it into vanilla JavaScript, which is what our browser can actually run. And you'll notice it looks very similar, but it's not exactly the same. So when I compile it, you'll notice that all of the types we assign to variables are gone, and it's taken away these blank lines. And the reason why is because it's a program that's running and iterates through your whole code and has a set of instructions it's following. And so it's taking all of this JavaScript and or taking all of this TypeScript, which is JavaScript plus some extra stuff, and removing all of that fancy stuff. And the way it does that is by generating code as necessary in order to make sure that everything works. In the end, adding these types doesn't like change the functionality of your app. All it does is guarantee that you, the writer of the code, are doing the right thing. And you can basically just take those away and you have vanilla JavaScript because all you're doing is adding like annotations that describe things. And when you take away those, the actual code that is functional is mostly still there. There's some more complicated stuff that happens. This is a really basic example. If I were to TSC like a whole React project that was using TypeScript, it turns all of that into a bunch of JavaScript, and that is really disgusting because there's a lot more that it has to convert, a lot more things to take away, a lot more code to generate. And so that can look really gross. Maybe we'll have an opportunity to do that at the end of the class. All right. So this is the point. I convert it into JavaScript. I could run this JavaScript now, sample.js, and we're going to get all of our numbers as expected. 1 plus 9 is 10, 27 plus 3 is 30, 0 plus 1 is 1, 3 plus 7 is 10. They're all orange, indicating their numbers, whereas higher up we had some stuff that was white to indicate that it was not a number. All right, so this is TypeScript. This is a super basic example. Any questions so far? All right, someone raise your hand. Go for it.
I was just wondering, we didn't use any type checking tools in our to-do app, but in the real world project, is it a must to use type checking tool? Like, for example, if we don't use TypeScript, how do they manage that? With the prop types or?
Prop types is an alternative. It is specific to React and only gives you a little bit of benefit that the props you're actually passing in when you're using a component are what you're expecting. And even then, it's not super helpful because it doesn't help you at compile time when you're actually writing the code. What happens with prop types is if you mess up and then you run your React app and then you like open your console, you get a really scary red warning in the console that says, oh, you violated the prop types that you set, which is, better than nothing, but like it doesn't help you when you're writing your code and actually creating the bug where you passed in the wrong value. You're still going to write all that code, you're going to test it out, and then you're going to eventually find your error. So it's a step in the right direction, but I would highly advise like literally any JavaScript that you write, you might as well just write TypeScript. It's a little bit daunting initially just because like you're writing extra code and it's another thing that you have to figure out. But for the most part, a lot of the benefits of TypeScript you get just automatically. Like over here, this variable X is a number and this variable Y is a number. And I didn't have to like do anything that's not valid JavaScript. If I like, this is exactly the same code over here, just swapped out the actual ways that you're declaring the variable because it's doing some code generation. And these are treated as numbers. And so when I try and add stuff here, if it's not the right type, then it's going to flag it for me. The only TypeScript thing that I did here was add number types up here. And then all the other benefits of checking these usages is automatic. So a lot of the cool stuff happens for you. I highly encourage just use TypeScript. I think if you find JavaScript in the workplace, if you're running a really old project, you might still be using JavaScript. But if you're creating a new one, I don't see any reason why you wouldn't use TypeScript. There's so many other benefits to using TypeScript beyond just props validation. That's what we're kind of doing up here. We can jump into like a React example to talk about like where TypeScript comes into play in React next, which I think will be more illustrative than this.
So then it's in the market, it's super common to use TypeScript.
I hope so.
Okay.
I personally use it anytime that I need to write some JavaScript, and I have worked on several projects that use it, but I've also worked on some projects that were really old and didn't. So I'm sure you'll find some of both.
Thank you.
Yeah. Other questions? Or we jump into a React specific example. All right, let's do some reacting. So what I thought we'd do today in about 20 minutes, so I don't know how far we're gonna get. But something that I think was really cool last cohort was going through a fleshed out React project that we've like done some cool stuff with and converting into a TypeScript project so we can actually see like where the types help you out. So I was thinking we might try this with our shopping app. I think we'll be able to get started. I don't think we'll get super far. I will post a link in here for you guys if anyone wants to do this alongside. The other thing that you might be interested in doing is converting your homework assignment into a TypeScript project. So you could do that alongside as well. We're not going to be like, changing the exact same things, but a lot of the principles will be exactly the same. So feel free to do either one or just, watch. That's also fine. But we're going to do all the same steps we did on our previous example. So I'm going to go back to that blog post. Not blog post, it's not a blog, it's GitHub comments. Inside of our shopping app, I'm going to create a new branch, convert to TypeScript. And we're going to npm install TypeScript and all of these types that we need. And then I'm going to open this in my VS Code. And we're going to create these config files. So what do we need? We need tsconfig.json. And this is like the main rules that it's going to follow when it's checking your code for possible type violations. And then we're going to create additionally tsconfig.node.json. Paste that in. Cool. So we have our two config files. We're going to fix our build script, which is just saying convert everything into JavaScript before you do your cool Vite stuff. And that's out of the way. All right, we got a big project here, done a lot of work on this in the past couple weeks, and we're going to very systematically convert these files into TypeScript. So maybe we start with this vanilla JavaScript thing first, since this is not a React component, and in theory, it should be pretty quick. So that's what I'm going to do. I'm going to do product data.ts. We're eventually going to get some problems. Yeah, there we go. So now it's telling us this ID has an any type. And additionally, we don't give a type for this data up here that we're actually using. And so if I return this dummy data, it's going to say, well, we're returning an array of objects with all these properties in them, which is cool, but we would like to have a really easy way to reference that. So let's do this first. This is really easy. If I'm looking at this code, we're loading a product by ID. Up here, these IDs are numbers. And so I could literally just go in here and say, this is a number, and it's going to fix all of our problems. But we want to do a little bit more. We want to give this dummy data an actual type. And we can do that by declaring a new type. We'll call this product. And this type is going to have several different properties. We can give it whatever properties we want. And any product that we create has to have these exact properties that we're specifying. So I'm going to say there's an ID property, which is a number. There's a name property, which is a string. There's a seller property, which is a string. There's a description property, which is a string. There's an image, which is a string. And there's a price, which is a number. This matches with what we have down here. I would argue that a description is not necessary. We could probably do without a description and just have a name and a seller and an image and a price. So what we can do is we can put a question mark over here. And now if I hover over this, it's going to tell me this is either a string or it's undefined. Now, what does that mean? If I create a new product, I can do that by declaring a variable, some product. And then I'm going to use that colon syntax we were doing before to say this is a product, not a project. It's going to give us red until we add in all these properties that are missing, because right now it is not a valid product. It does not have all these properties. So I can give it an ID of 0, a name of some product, a seller, which is me, and an image, which is some url.com/image, and a price, which is $1. If I do this, it's no longer yelling at us because this is now a valid product. I can put a description in here if I want to. You'll notice even when I type the description, it has that little question mark, which means it can either be a string or undefined. This is called a union, be one or the other. And if it can be undefined, then that means I don't have to give it an explicit value when I create this product. I can, I don't have to. All right, so we have this type. All these objects are of this type. This is an array of product objects. So let's make it clear that that's what this is. This is an array of products. Now, if I hover over this, instead of having that really long list of all the different properties, it just says that it's a product. And anywhere in my application, I can now refer to a product very easily. I could go into a totally different file and I could create new products, which is a copy of a product. And it's not going to like this because we did not export this type, I think. But if we export it, nope, still doesn't like it. Don't recall having to export these types in the past. Oh, it's because this is not a TypeScript file yet. I'm so smart. Well, let's do this from a different file. Let's go into our main.jsx. We'll turn this into a TypeScript component by making this tsx instead of jsx. And this is going to have some problems. Notably, these are importing .jsx files, and it's not liking that, so we're going to have to convert those into tsx as well. But at least in the meantime, we can do some easy stuff. And clear up this, and then if we want to, we could create a new product. And we could import this, and now we have our new product. Just want to double check. Do we actually have to export this? I feel like we don't. Nope, we do have to export it. Darn. All right. Well, we export this type. This type is available across our project now. We have these functions. These functions now say that they return a product array and a product or nothing. Down here, we return nothing if there is no ID that matches. Great, we can deal with that. So what do we do down here? This is some old stuff. And most of it works because, again, we imported types for our React and React DOM. And this already comes with types, so I don't have to worry about this. But down here, it was telling us that this call to get the root element, which is from this index.html, it's a div with ID root. It might not work. We might not find an element that has root. In this case, we will because we declared it in an index.html. We know better as React developers. If there wasn't a root element, React wouldn't work because it wouldn't know like where it has to create new HTML elements in order to create your layout. And so I know this is going to be valid. And so I'm going to say that this is explicitly an HTML element. It's kind of like casting, like we were doing earlier by taking a number and putting it into a string. But here we're saying it can be either one, but I know it's going to be this. And so that's why this goes away. All right. These are all red. We got to fix all of these. We just got to pick one to start with. I'm gonna maybe opt for this cart.jsx since it's the next one up the list. We were already in there a little bit. I'm gonna convert this into a TSX file. And we have a lot of problems, but that's okay. These are very fixable. So up here, this is a property, and we have no idea what this property is going to be. I, like myself, know that this is supposed to be the React elements that go inside of this cart provider. So when I use this in my main.tsx, I can add extra HTML elements inside here. So I have my cart provider, and then I like put additional React components in there, and that gets populated into this children property. But React doesn't know what that is yet. And so instead, what we're going to do is we're going to Google this because I don't remember off the top of my head how to fix this, but I know that Stack Overflow is going to. React.react node. Okay, that's along the lines of what I was thinking. So this is a variable. I should just be able to auto import this. I don't know why it's not doing that down here. I would expect this to work. You couldn't tell, my TypeScript is a little rusty. Oh, you know what it is? We have to just declare types for this whole props object. There's a bunch of different ways we can do this. I'm going to do the syntax that I think will be the most comprehensible. And so we're going to just turn this into a props object. And we're going to call this cart provider props. So we're going to say this props object is of type cart provider props, which doesn't exist yet. And then down here is where we're going to actually pull those properties out and say that there is a children property in our props object. The other way that I could have done that is this really gross syntax where I say, well, I'm going to destructure children and pull it out of the object. Well, what is the type of this object? The type is cart provider props. But I think this is a little more confusing because it's like you're declaring the object that you're destructuring, and then over here you're declaring the properties, which you could also like create as an object and say children is equal to React node. You do this, but this is even worse. I think this is like borderline incomprehensible. So let's go back to the way we're doing it originally. We have a props object, we pull items out of it, we have a type. We don't know what that type is yet. So let's create the type. Well, what's going to be in here? Well, the only property that we actually use right now is our props. So we can pretty easily say the only property in here should be children. And this is a type React node. React node is just like a general type that represents like any thing, any component or any HTML element that goes into your render. And so that's what's actually getting passed in here as expected. Oh, I have a typo. And now that squiggle goes away. If I hover over children, it tells me it's a React node. Cool. So now I know that the only thing I can pass into the cart provider is children. That's it. It's the only thing that works. If I go in here and try and find my cart provider, this children property is getting populated automatically. If I try and pass in something else, a property that I'm not accepting in my object, well, it's going to tell me that the props object is no longer valid because it has these two properties, but food does not exist on this property type that I declared. So TypeScript automatically caught for us that we passed in the wrong thing. If I did want to pass in foo, I would have to explicitly tell myself, okay, I want foo. This is going to be a string. We're going to use it somewhere. Maybe we pull foo out of the props object, and now foo is valid. Foo is a string. It also prevents you from passing in a number accidentally. That's not valid. I can't do that. Also, if we expect foo and we don't pass in foo, then it's going to tell us that property foo is missing because we say that it has to be a string. It can't be a string or undefined. If it can be undefined, then this is fine. But if it has to be a string, then it's going to flag it for us and tell us we didn't pass in that property. This is like the biggest reason why in React this is useful, because if I did this, vanilla JavaScript would say, yeah, that's totally fine. And then we try and use foo somewhere. Maybe we like, say, my message is equal to hello plus foo. And then we try to console.log my message or do something really important with it. This is going to be problematic because this is going to be undefined. We're going to do hello, a string plus undefined, and that's going to be really gross. I could actually pull this up in my JavaScript console and see what's going to happen. What if I do this? It's just going to literally append the word undefined into my string, which is going to be disgusting. And that's a bug that someone's going to come across using your application and be really confused. So again, the whole point of TypeScript, it just eliminates a whole set of errors from possibly happening. Sometimes you still just write bad code that doesn't work. But if you write buggy code because you accidentally did something wrong, TypeScript is going to catch it for you. And in almost every other language, except things like Python that also don't have types, these things get caught for you without installing TypeScript and going through all these hoops. This is just like a way of fixing deficiencies with JavaScript because it doesn't exist in vanilla JavaScript. We're kind of out of time, so I don't want to go any further. If I were going to continue converting this project, I would go through and turn these all into .tsx files. I would go through and look at all of these red squiggles and try and figure out what's going on. A lot of these are just going to be, well, we expect that this is any, and you haven't given it a type, or you're assigning an array of these weird object types, but you haven't explicitly said what the type of the state variable is. I could say this cart is an array of products in cart. And now, anytime I use the state variable, we're going to see that this is an array of products in cart. And when I set it, I have to give it an array with objects of that type. And so I can't accidentally do set cart with an array with null in it. Null is not valid, or string, or anything like that. So you can do it with state variables, which is awesome. I think the biggest really cool part is that you can, when you're fetching things, so if I have a call to fetch and I say get some URL and I do my dot then, I have my response, and I do res.json, and then I do dot then again, and now I have my actual data, and I do a function. This should look sort of familiar to you guys. If I hover over this data, this is any. This is the data that I'm actually getting back from my API, and it could be anything. It could change at any time, and my code would never have any idea. If I make a change to the data that my API is giving me, I should like be able to tell my code, okay, the API has changed, highlight anywhere that needs to be updated now that that data has changed. And so if I expect that this is an array of products that's coming back as my data from the server, um, maybe there's something else I have to do here. Promise like void. think it wants this value any. I think maybe I do like product here or product array. Again, I don't remember the exact syntax, but there's some way that you can do this such that you actually declare what the scheme of your data is. And then when you're like doing some crazy stuff like set cart is equal to cart plus data, I know that this is valid. So I think types come in most handy when you're actually working with like an API that's sending you data and you can declare to yourself, okay, this is what the API is sending me. And then if you try and access a property that doesn't exist, or if the properties change and you update them, it'll flag it all for you, which is really awesome. Okay, that's all I got. This is a lot of me talking today. I'm sorry. I just think this is really cool, and I hope that you guys take some time to try and integrate this into your homework
I
when you
have
have
a
a
question.
chance. Yeah, go ahead.
So in one single project, can we use both TypeScript and JavaScript,
I
which
mean,
is like you did?
possibly, but if we try and do .tsx and import .jsx files, so .jsx, if I go in here, even if I have all these violations, it's not going to flag them for me because, TypeScript isn't checking them. Well, this TSX file can't import .jsx. So those two things are not going to mix together. There's probably ways that you could still use a bunch of JavaScript in your TypeScript project. Um, one of the goals of TypeScript is to be able to introduce it incrementally, which means you don't always have to just like convert the whole project at once, which is why like if that was a requirement, then all these projects that have been around for years and years since JavaScript was created, in the 1990s or whenever it was, it might have been earlier than that even. All these things that are like monolithic and enormous and are made purely of JavaScript would never have any hope of becoming TypeScript because that would be so much work to do at once. So you can definitely convert incrementally. There are going to be some hiccups. I don't explicitly know how you would import this .jsx. There's probably an easy way to just ignore this. And then you can use both at once. But in general, the goal should be get your whole project on TypeScript, maybe incrementally if you need to. And that way your types can be shared across your whole project. Good question though. Other questions? All right. Sounds like there's no other questions. If you come across anything, or if you decide that you want to undertake this on your homework and you're running into some issues, feel free to reach out. I'm happy to work through them with you. The cool thing about TypeScript is it's usually pretty descriptive. Uh, Sometimes parsing through these messages can be a little annoying, but it does tell you there's a property missing in this type. What is this type? That might be a little confusing to you, but then you look over here and see, oh, my cart provider props expects only children, and we're missing the actual foo property. So you can kind of parse through it, and once you see some of these errors a couple times, it gets a lot easier. But if you get stuck, feel free to reach out. I'm available. All your mentors can help. Most of them, if not all of them, have worked with TypeScript before and are also just as gung-ho. All right, that's all I got. Thank you. Talk to you guys next week.
Thank you so much.